Okay. So this time, okay, let's have an overview, now a recap about fluid pressure. So what are the factors affecting the fluid pressure? No? So why does the water continue to flow? No? If there are spaces. Okay? So in this reason, okay, we all understand, no? Based on the given, no, preference, for example here, okay? For example, we put 3 holes, okay, in vertical position. So I'll repeat, there is the amount of water inside this container. Okay, with A, B, and C, and those are holes at different height. So the highest height, okay, water from A pulls closer to bottle with least pressure. So the speed is quite slow. Okay. However, in B, there is a moderate pressure, right? In which water from B, from A going to B, okay, the pressure exerted turns average speed, or the water spurts out moderately. The last one, after the water reaches to hole B, okay, it will continue to flow down to C, okay, as you have noticed in here. So, from C, from B going to C, the water from C farther from the bottle, okay, it has a greater or higher pressure already. So, what is the indicator there? Okay? The highest height, slow speed. Okay? Average height, moderate speed. While the slowest height or the shortest height, okay, this is an indicator that it has what? Fastest speed. Okay? So this is the reason why, how those things are exerted when it comes to fluid pressure. So the pressure exerted going down. Okay? Since the pressure, the air pressure also helps to push the water going down. So the pressure is lowest towards the top of the bucket. Water leaking from the highest hole, which is under low pressure. However, pressure is highest at the bottom of the bucket. Then, water spurts at the highest pressure from the lowest hole. So, this is basically the preference of our example. Now, let's move to what we call the pressure increases with depth. As I've said, when we make 3 holes from a container which is completely filled with water, holes must be equal in size but at different heights. What does that mean? It can be noted that water coming from top holes comes with less pressure, covers with less distance. And the water comes from the last hole with greater pressure. So try to understand this one, where pressure increases according to its depth. Now let's move to buoyant force. What is meant by the word buoyant force? I already discussed this to you last time. Buoyancy. Buoyant force. Buoyed up. So, lift up. By whom? Okay, with a certain pressure under or at the bottom. What matter? Fluid pressure. So the pressure or the amount of water or liquid, no, helps the object to lift up. Okay? So there's the word buoyant force. What a buoyant force is? A buoyant force, it is equal to the weight of displaced fluid. Have you noticed, guys, why some objects sink, why some objects float, why some objects submerged or partially submerged? Okay? It is because things that usually matter about that, it's because of objects, the weight of an object. Okay? As I've explained before, if you may wonder, why does the ship or a boat enables to float? Okay? Then there were instances that some objects sink. So what do you think will be the reason behind that? Of course, the weight of an object, the mass of an object, right? Then, of course, the mass of water. So you will understand later what affects the sinking, floating, and submerged of object. Okay, what are the factors affecting behind that? We need to try to observe the buoyant force exerted. Okay, as you can see here, the buoyant force exerted from where? From water pressure underneath. That's why we call it buoyant force, upward force. The buoyant force or upward force. Then, another one, we have this. So what are the different types of buoyancy? One, positively buoyant or positive buoyancy. Next one, positively buoyant or what we call, what will happen to this one? Okay? Partially submerged. Then we also have negative buoyancy, in which this describes full immersed or full submerged of object, in which this is already the indicator of sinking. Sink. Then this one, neutrally buoyant. So when we talk about neutrally buoyant, okay, you may observe that the buoyant force still exerting while the weight of an object almost equal. The amount of the water pressure or the buoyant force is equal to the weight of an object. That is why it's neutral. So that's the reason why we call it as neutral. Okay? So, again, we have positive buoyancy, negative buoyancy, and neutral buoyancy. So, when we talk about positive buoyancy, this enables the objects to float. So, this is the principles of floating. Okay? Then, the other one, for negative buoyancy, principle of sinking. Then, neutral buoyancy, this is what we call a partial, okay, immersed of water and between the object. So, this is the equilibrium, equal, not sinking nor floating. That is why we call it as neutral. Okay? So therefore, buoyant force related to weight of water displaced. I'll repeat. Buoyant force is related to the weight of water being displaced. So if you have 1 glass of water, okay, you put half, okay, amount of water in your glass, half full or 50%, no? the amount of water inside the glass, then you put a stone, no? Big stone inside it, or big rock inside it. What have you observed? Okay, so the amount of water increases. Okay, the water level increases when you put another object inside the glass of water, right? So that's what we call, means to say that the fluid pressure, no, the water pressure exerted, no, when it comes to buoyant force, the weight of water displaced. Alright? So, what is the formula? Okay, buoyant force is equals to fluid pressure with the gravity and the volume of water. Okay? So, where V is the volume of submerged object, then this one, V is equals to the mass of an object with the fluid pressure, then that's what we call the buoyant force. Okay? So it can be expressed as buoyant force is equals to mass and the gravity and the fluid pressure and, of course, okay, the object's mass or the object's pressure as well. So this is literally how we express the constant equation of the buoyant force. No? How is it being measured? So, in other words, no, buoyant force can cause an object to float or sink or partially submerged or fully submerged. Okay? So, those are mainly the indicator about the buoyancy, no? The law of buoyancy. So the density and buoyancy force, the buoyancy experienced by an object is equal to the weight of the fluid displaced. So what does that mean? I'll repeat, the buoyancy force experienced by an object equal to the weight of the fluid displaced. When you talk about fluid displaced, means to say the amount, how much is the increase after you put or you let the objects gets in that fluid. Okay, so that one, it is the diagram in this area. Red area represents the volume of water that has been displaced. So you may wonder, guys, okay, this is a ship, cargo vessel, for example. Not literally that this one will really flow. There is a certain level of an object in which the water, okay, literally takes place, but not in this area.